So far, we've seen that GeneXus establishes relationships between transactions and between tables based on the names of the attributes. For example, in the attraction transaction, when it finds the category ID attribute, it knows that this exact same attribute is in the category transaction as an identifier. This is what makes it determine that attraction will then reference category, placing it in the table as a foreign key. When it finds the category name attribute in the attraction transaction, it discovers that this same attribute is in the category transaction, which is already being referenced through the foreign key category ID, so it makes the category name attribute inferred. It will not place it in the attraction table, but will retrieve it from the reference. A similar analysis applies to these four attributes, which also exist in the country transaction. The fact that country-id and city-id are identifiers at each level there means that in attraction they become references. And this will make country name and city name become inferred attributes. If these attributes correspond to the concept of identifier and category name, those that were placed in attraction with the same name are understood to represent those same concepts, and that's why GeneXus automatically establishes those relationships. But what if, in a transaction, we needed to express the same concept for one attribute as for another, but without being required to name them the same? For example, could we have written these attributes in attraction with different names and still have them fulfill these same roles? In other words, can we somehow indicate that attraction category id is an alias for category id and that attraction category name is an alias for category name? The answer is yes, by defining what is called a subtype group. We would define a group to which we give a semantically appropriate name, for example, attraction category, and within it we define that the attribute named attraction category id is a subtype of the attribute category id, which is equivalent to saying that it is an alias of that attribute. And on the other hand, that attraction category name is a subtype or alias of the attribute category name. With this, we achieve what we wanted. In every place where the attribute attraction category ID appears, it will be understood as an alias of category ID. And the same goes for the other attribute. Of course, subtypes are only defined if an alias is necessary. That is not the case in this example. Let's look at a case where we will actually need it. Suppose that at the travel agency, we are asked to register the flights they offer to clients, for example, to visit a set of tourist attractions. For each flight, it is necessary to record the airport from which it departs, as well as the airport where the flight arrives. Two new entities then come into play, one that represents each airport and one that represents each flight, which will be related to each other. For each airport, we will record its name, country, and city. From this transaction, GeneXus will clearly generate this table, where country ID and city ID together will be a foreign key to the country-city table. So far, nothing new. Let's go to GeneXus and create a new transaction object called airport. And in the source, we simply write the names of the attributes. And let GeneXus infer their data types. We save and see the structure just as we expected. Now we want to represent the flights. What information will we need to record? Basically, just its identifier, the airport from which the flight departs and the airport to which it arrives. Here, the problem already starts to appear. Clearly, a flight will need to reference the airport entity twice. The departure airport will reference an item from here, that is, an airport, and the arrival airport will reference another one, which we will even want to ensure is different from the first. If, for example, we only needed to record the departure airport for the flight because we weren't interested at all in the arrival airport, then it would be very simple. We would do what we always do. We would add the airport ID attribute to flight, which would be a foreign key to the airport table, and therefore airport name would be an inferred attribute. But in our case, we need the other airport as well. The problem is that GeneXus will not allow us to enter the same attribute twice in a transaction. And even if it did, how would we differentiate one from the other, for example, to ensure they are different? The problem we have here is an ambiguity in flight. One of the airports plays a role, that of being the departure airport, and the other plays another role, that of being the arrival airport. So, to distinguish them, we should change the names of the attributes. For example, flight departure airport ID for the departure airport ID and flight departure airport name for its inferred airport name. As we saw before, in order for them to still correspond to the airport concept despite having different names, we will need to create a group of subtypes that jointly define them as airport ID and name, respectively. Otherwise, they will have no relation to the airports. Let's start by doing this in GeneXus. Let's create the flight transaction. Let's enter flight ID as the identifier, and then comes the attribute that will be an alias for airport ID, which will correspond to the departure airport. We press dot so it starts with flight, and then the name continues with departure airport ID. Next is the one that will end up being an alias for airport name, dot departure airport name. Let's try saving now before completing the structure with what we're missing. We see that by default it's set flight departure airport ID as the descriptor attribute, meaning the one that best describes each item. Later on, we'll change it to another one. For now, these two attributes are not aliases of any others because we haven't defined them as subtypes of those in airport within a group. Even though their names end the same as the attributes they will be aliases of, this doesn't mean anything to GeneXus. For GeneXus, it makes no difference whether this attribute is called Flight Departure Airport ID or X. It's exactly the same. Until we tell it that it's an alias of airport ID, it won't establish any relationship. To make sure what we're saying is correct, let's create a diagram of the airport and flight tables. We can see that there is no arrow relating them. Let's save the diagram because we'll look at it again once we've established the relationship. For now, we'll close it. Let's create the first subtype group manually. So we'll create a new object of type subtype group and we'll name it as such. In this single PA, we see a graphical editing window. Let's press Enter to enter the first subtype. When we type a period, we see that it automatically suggests the same name as the group. We see the AKB attributes appear that start like this. We select Flight Departure Airport ID. We see two essential columns, one named Subtype and the other named Supertype. Here, we are indicating that the AKB attribute named Flight Departure Airport ID will be a subtype that is an alias of another attribute, which we call its supertype. Here, we need to specify which attribute is the supertype. In this case, it will be Airport ID. Now we need to enter the other subtype, which will be an alias for airport name. We press Enter and then period, and it already brings up Flight Departure Airport, so we complete it with name. Its supertype will be airport name. Let's save. Now let's look at these same definitions, but in the source window. It's an even simpler way to define the group. The attribute on the left is the alias or subtype of the attribute on the right, which is the supertype. If we now reopen the diagram we created earlier, we can see that the referential relationship has now been established. A flight has an airport. If we open the information for the flight table, we see the same thing. The attribute Flight Departure Airport ID, a subtype of Airport ID, will be a foreign key. In fact, if we go to the Indexes tab of the table, we can see the foreign key index for the attribute Flight Departure Airport ID. And we can also notice that in the flight transaction, the indicators for foreign key attribute and inferred attribute are now appearing. Since you chose Flight Departure Airport Name as the descriptor attribute, we are now seeing this icon. But if we make this attribute no longer the descriptor, we can clearly see that it is inferred. We can also see that an S was added to indicate that they are subtypes. Now we could perfectly well place airport ID and airport name in the flight transaction since there will no longer be any ambiguity. We would have airport ID referencing airport and receiving an airport name the value of the airport name from this table. And on the other hand, this attribute a subtype of airport ID, therefore also referencing airport and receiving in this other one a subtype of airport name and grouped with the first the corresponding airport name. This would be a possible solution. The ambiguity is eliminated. We only change the name of the attributes referencing the departure airport. The attributes whose names we did not change will correspond to the arrival airport. But we could also change the names of these attributes to highlight their role as arrival airport and to put them on an equivalent level with those in the other group of subtypes. Again, in order for them to represent aliases of the attributes airport ID and airport name, the group of subtypes must be defined. We can create it as we did before, or ask Nexa to do it for us. Here, we've already added the attributes to the flight transaction, and we're going to create the subtype group manually as we did with the other one. But this time by writing directly in the source. Flight arrival airport ID, a subtype of airport ID, and flight arrival airport name, a subtype of airport name. We save. If we look at how the structure tab turns out, it's correct. Notice that the key symbol is appearing for the subtype of the airport ID supertype. And if we now reopen the flight transaction in its structure, we see what we expected. In fact, if we open the flight table, we see these two attributes, each of which will have a foreign key index defined. Let's test all of this. F5. The database will need to be reorganized since the flight and airport tables will have to be created. Airport with these 4 attributes, and flight with these 3. We agree, so we press reorganize. Once it's finished, let's start by creating airports. Let's enter the airport named Guarulhos in the country Brazil and in the city of São Paulo. We confirm. Now let's register the Charles de Gaulle Airport. We select France and the city Paris. We confirm. Now let's move on to registering a flight. We execute the flight transaction. The ID is auto-numbered, so we leave it at 0. And we can already see that here we have to specify an airport ID. The label doesn't indicate that this is the departure airport, so we'll need to clarify that. We see that, since it's a foreign key, the classic button appears to open the selection list in case we don't remember the ID we want by heart. We'll choose Guarulhos as the departure airport, and here goes the arrival airport. It will be Charlotte de Gaulle. We confirm. We see that the flight has been entered with ID 1. Now let's go to Ginexus to change the labels of these 4 controls so that the role of each one is indicated. If we go to the web layout of the transaction in Ginexus and place ourselves on the field for the first airport, we see that the label caption property indicates that it takes its value from the contextual title property of the attribute to which this control corresponds. So let's look for it among the attribute's properties. We can access them, for example, by searching for it in the structure. Here it is. Let's add departure to it. We do the same for the name. And for these other 2, let's add arrival. If we now go to the web layout, we can see that the labels have indeed changed. Let's request to run it again. F5. Now let's enter another flight. Now it's very clear for each field whether it refers to the departure or arrival airport. Let's try entering airport 15 for the departure. An error message is displayed informing us that this airport does not exist. Data consistency is being checked, and as we've already seen, the selection list is also offered to us. That is, the fact that the departure airport here is a subtype of airport ID instead of airport ID itself makes no difference when assigning it the role of foreign key. It will behave exactly the same as if it were airport ID. And this is precisely the idea. By defining subtypes, we manage to define that different attribute names correspond to the same concept. The same will apply for this other one. Could we enter the same arrival airport as the departure airport for the flight? Yes, it's a rule in our business that this shouldn't happen, so we would have had to specify it in the transaction if we wanted it to be enforced. That is, we would add this error rule. And now, if we try to set the same airport for the flight, it no longer allows us to save. Let's change the arrival airport for this flight to Guarulhos. Now we will be able to save. In this example in flight regarding the departure airport, we only needed to infer its name, and that's why we defined this alias airport name in the subtype group, which is what we placed in the structure of the flight transaction, where it will be inferred. The group requires that it must randomly have an attribute, the airport ID subtype, which is the primary one, the one that will be the reference for airport. Then it will depend on which attributes we want to infer from that reference, which ones we need to add to the group. For example, if we also wanted to infer the country and city name of the departure airport to display them to the user on the screen, we would have to do the same as we did for airport name, that is, add subtypes for each one to the subtype group. Let's do it in GeneXus. Let's open the subtype group corresponding to the departure airport and there define a new attribute, Flight Departure Country ID, which did not exist in the KB until now. It will be a subtype of the country attribute. And the same goes for the rest of the attributes we want to use in Fly. Flight Departure Country Name, Flight Departure City ID, and Flight Departure City Name. Let's save. Now these new attributes exist in the KB, although they are not yet in any transaction. So let's add them to the flight structure in the place where we want them to appear. Let's also add departure to each one's contextual title property, like this. We can see this in the labels. Let's try this, F5. We see that all the departure airport data appears. The attribute that will be a foreign key is this one, Fly Departure Airport ID, a subtype of airport ID. And all these others are inferred from it. We would have to do the same for the other group of subtypes, the arrival airport, if we also want to infer the country and city of that airport. That is, to this group we will add the 4 subtypes exactly as we did before, and we change the properties with textual title. In the flight transaction, we add these new attributes. For example, directly from the source. This way we can see the structure. If we open the table, we will still see the same 3 attributes in it, the primary key and the 2 subtypes of airport ID, which are foreign keys. All the other attributes are inferred respectively from each of those foreign keys. So, we have seen a case in which a double reference is needed from one entity to another with 2 different roles, so we need to rename these references. This meant that we had to define a group of subtypes for each of those 2 references, each necessarily with a subtype of the primary key attribute of the referenced entity, in our case, airport ID. And optionally, subtype attributes that we might want to infer from the referenced entity. Here, it's only airport name, but as we've just seen, it could be all the others or just some of them. Strictly speaking, it wasn't necessary to change the names of both references. We could have changed the name of just one of them. For example, the first one but not the second, or vice versa. The second one but not the first. We would have also solved the original problem of the double reference that way. If in this case we lean towards the solution where we define aliases for both references, it's because this way both roles are clearly identified, and neither one carries more semantic weight than the other. But the other options were also valid solutions and more economical since we only added a single group of subtypes. There are many other cases in which it is necessary to define an alias for an attribute. The one we analyzed is a particular case of a more general one, where we have several references from one table to another, which may be mediated by other tables, as we see in this diagram. If from one table we have two different paths to reach another, then we are dealing with one of these cases. Another case is self-reference, a table that references itself. For example, if for an employee entity we need to include a reference to the manager who is also an employee. Another case is the specialization of an entity into more specific entities. Here we are only mentioning them because we will study them in more advanced courses.